Mr. B. Dhanasegar is working as a lecturer in Department of Information Technology, Anna University, Chennai. He finished his MCA from Urumu Dhanalakshmi College, Bharatidasan University. He finished his ME in Computer Science and Engineering from College of Engineering, Anna University. His areas of interest are multi-core programming and architecture, programming models, compiler, automata theory, cryptography, and algorithms. He is an expert in subjects like compiler design, formal languages and automata theory, analysis of algorithms. His research area is code generation for multi-core architecture.
Welcome to the UGC lecture series on computer science. We are studying the various parsing techniques. So, the two categories like the bottom up parsing and another one is the top down parsing. In top down parsing we have seen the predictive parsers, and in bottom up parsing we have seen the parsers like shift reduce parsing, and another one is the left to right, that is parsing of the rightmost derivation, that is called LR parsing technique. And within LR parsing technique we have seen three categories of parsing tables. One is going to be the simple SLR, simple LR, and another one is canonical LR, and finally we have seen that is LALR parsing table also. But one important factor that we have to remember here is all these parsing table constructions will succeed only if the grammar has no ambiguity. So, the grammars may have that is ambiguity. Even there are languages for which the grammars are always going to be ambiguity, which we call it as inherently ambiguous languages, and the grammars are called inherently ambiguous there is grammars. But now the question is, suppose if you are given a language for which there exists a grammar and the grammar is having the ambiguity. So, if the grammar has ambiguity, one idea is you go for eliminating the ambiguity available in the grammar, and to produce a new grammar which is not having any ambiguity. So, the languages are going to be deterministically that is generated or parsed, which means that during the parsing process at any stage, whether it is going to be the shift action or reduce action or even the accept action, there will not be any kind of conflict like shift conflict or reduce conflict or even shift reduce conflict. So, these things are certainly not at all rising, because we find that the grammar is unambiguous and the parsing table construction will be succeeded. So, we will not be having problem with that. But there are cases where the languages are inherently ambiguous, or sometimes we will find that finding the equivalent that is unambiguous grammar for a given ambiguous grammar may be very difficult. So, now the question is, can we go ahead with that is parsing table construction for the given grammar which may have ambiguity. So, now it is possible. The solution is provided by the automatic parser generators. So, we have tools for even that is constructing parsing tables for that is ambiguous grammars also. So, we generally call it as automatic parser generator. So, what their role is here, we may be given with a ambiguous grammar and mostly it will fail, that is when your grammar is ambiguous, definitely they will be that is failing to produce a valid parsing table. But sometimes they will be very much that is useful if you are having the grammar with ambiguity, but the condition is we want to have a compiler generator or the compiler writing system. So, that produces the parsing table for ambiguous grammar. So, when we have such an option, we will be able to that is produce parsing table or produce the parsers with our own precedence and associativity. So, mostly the ambiguity available in the grammars are because of the ambiguity in between the precedence and associativity, like you can take about the expression grammar where the priorities of the various operators are going to be different, and even the associativity is also differing for different, that is among the various operators. So, how we will be handling the situation? So, that is one thing, and another one we may be aware of the dangling else grammar where the that is grammar for if statement is having the ambiguity because of where do we nest or where do we associate the else, whether it is with the nearest if or with the farthest if, that is going to be the issue. So, now how these are going to be handled? So, one solution you should go for finding the equivalent grammar, but this is going to be an unambiguous grammar, and the other solution is you proceed with ambiguous grammar, but we must provide some additional information to the parser generator, so that the parser generator will handle with the help of additional information how these ambiguities are resolved when such ambiguities are raised during the parsing action. The ambiguities may be mostly because of the shift reduce conflict may rise. So, for a particular statement, there is input symbol from the buffer, there are two possible actions valid. We may find that it may be either a shift action or it may be a there is reduce action. So, maybe one of them will be the correct action. Syntactically speaking, both will be valid, but semantically there will be only one valid, but now we have to decide on which will be the valid action. So, this valid action is decided based on some dynamic information provided as additional there is data to the parser generator. So, the parser generator will handle all these or incorporate all these information into the parsing table, and when there is a need for resolving a shift reduce conflict or a reduce conflict, now automatically the parser generator will handle the situation because of the additional information. So, now how this additional information will be provided to the parser generator. So, we have a compiler system called YARC, yet another compiler that is constructed system that is which is going to be a compiler writing system which is capable of producing the LLR parsing table for the given grammar. And the specialty about your LLR parsing, the YARC compiler writing system is, so it is not required that the grammar be we are giving for this YARC system should always be unambiguous grammar. It can even be ambiguous grammar also. So, in this case we can provide ambiguous grammar also. So, if you find that there is no conflict being produced when we are constructing the LLR parsing table, then no problem. See, for example, if the grammar is not having any ambiguity, then it is not going to produce any parsing action conflict during the parser that is generation, that is parsing table construction. But if we find the grammar as ambiguity, then certainly the grammar or the LLR that is parser will produce parsing table with certain kind of that is conflicts. So, now what we need to give is some additional information about the precedence and associativity of various operators and terminals. So, why we are more specific about precedence and associativity means, most of the time the ambiguities are because of the precedence and associativity of the various operators available in the grammar. So, now we know we have to explicitly find out which operator takes more priority and which takes lesser priority, or only in terms of the associativity, that is when we find two operators having same priority. So, how do you handle the computational that is computation, whether it is first to be carried out or to be last to be carried out, that is from the order left to right or from the order right to left. So, these things are that is known to the programmer who has written the grammar, and now all these are supposed to be provided as additional information for the parser generator, so that the parser generator will not end up in that is any kind of conflict. So, if you find there is no need for there is no conflict being produced, then no need of giving additional information. Now, see that how we are providing that that is information. So, this YARC has the facility to assign precedence to productions or even terminals. That means, we can have way of mentioning, so which production takes more priority and which terminal takes more priority, or what is the order of the priority, like first production, second production, third production, or first terminal, second terminal, third terminal. So, if you are having a terminal in the first position, then we can say that it is having the highest priority, and whatever is following it is having the lesser priority than the previous one, and we have third one means it is having lesser priority than the first one and even the second one. So, we have provision for mentioning the precedence to productions as well as terminals, and it is not required that all the productions be given the precedence or the associativity, it is not necessary. So, we even if the grammar is ambiguous, there are only few productions which are the cause for the ambiguity, but not all the productions. So, we have to find out the mechanism for providing the precedence for productions which are really having the problem, but not everything. So, find out what are all the productions that may involve in parsing action conflict, and for those productions we have to go for giving the that is priority. In the absence of the precedence to some production, the precedence of the rightmost terminal will be considered as the precedence of that production. So, once we started mentioning the priority for any production, automatically the parser will be looking for that is mentioning what is the precedence for the various productions. So, if there is no mention about what is the precedence for a particular production, then automatically we will be considering the priority of the rightmost terminal, which is available on the right hand side of the production as the precedence of that particular production. So, even if you do not specify the production's precedence, it will be there taken from the rightmost terminal of that particular production. So, here we have a simple example. The example it says that we are taking the dangling else grammar. So, this grammar is the if statement, if key followed by the condition, and if this condition becomes true, we will execute the very first statement, and else we will execute the second statement. That is what if, that is I, S, E, S. So, it is not necessary that always we must have the else component for every if statement. So, the language can have if statements even without else also. So, in that case the syntax is going to be if condition then a statement, and the statement can even be any statement other than the if statement also. In that case it is going to be any other statement, and we know that this grammar is going to be an ambiguous grammar because of the else. So, when you have only one type of statement called if condition then statement else statement, no ambiguity, or when you are having only if statement, then also there is no ambiguity. But when you combine that if statement else statement along with if statement, there is a chance that these particular productions may end up with that is reduced conflicts. When you look at that reduced conflict instead of shifting, so what may happen is we will be left with some else followed by a statement which may not be able to be associated with any other part of the statement. So, that is the reason why we find the ambiguity with this grammar. So, now what should be that is the solution for that is we must give always the precedence, that is S derives I, S, E, S with more precedence than the precedence for S derives I, S. That is, whenever we find that the statement as else part, the else part should be given the higher priority, so that the statement will be considered as a complete statement with if condition then statement and else statement. By the way, we will give lower precedence for if statement without the else part. So, when we have a statement with else part, the statement will be considered for reduction together with the else part, and when we have a statement without the else part, then we will not be looking for else to produce a valid statement for reduction. So, when you have two productions S derives I S E S and S derives I S, the first one takes higher priority. So, that can be mentioned either in the that is additional information provided, or you can list it first, so that it will take automatically the highest priority. And when you are going for looking at the terminals, so we have the terminal called E, so that is going to have higher priority. We have the terminal called I and another terminal called E, and when I is on the stack with E on the buffer, that is from the input. So, what should be done is with I on the top of the stack with E on the current input symbol position, we must certainly go for a shift operation rather than the reduce operation. If you proceed with the reduce operation, the problem is else will be left isolated, so which cannot be combined with any other part of the rest program by the syntax. So, we must go for giving priority for E, so that the E will be combined always with the if part, so that we will be able to produce a valid statement called if condition then statement else statement. So, now how we are mentioning the precedence and associativity. First thing is we are going for that is saying that S derives I S is going to have lower precedence. So, for that we list it production like this: S derives I S E S, that is the first item, and whereas S derives that is we have I S, so that is going to be our second one. So, by this listing we will be able to understand that S derives I S E S is going to take the higher priority than the priority for S derives I S. In terms of the terminal, we have to say that E is going to take always higher priority. So, terminal E means E takes higher priority, and dummy it is simply introduced just to say that S direct IS is going to take the lower priority. So, this is how we are mentioning the priority for the different operators as well as different terminals as well as different protections available in the grammar. Now, we can understand that a grammar even with ambiguity, it is possible to produce the parsing table provided we provide some additional information to the parser. So, I will continue this lecture after a short break. Welcome back. We were studying how the automatic parser generator produces parsing table even in the presence of the ambiguous grammar. The next topic is how do we handle with errors. So, you may have some inputs where the errors are there, but it is required to find out the errors or detect the errors and report the errors to the programmer, so that the programmer will be able to correct the error. But if you are able to come up with a that is compiler which can correct the errors which are available in the program, then it will be much easier from the programmer side. But error correcting compilers are there, but they are more complex than the compilers which are simply producing the errors to the programmer for correction. So, now we have to study that is what is going to be an error and what will be the mechanism or how these errors are handled by the compilers. First, let us start with the basic things which are required for an error detecting compiler. The compiler, that is if you are talking about any compiler, the first thing is it is differing from the interpreter in the sense that the interpreters most probably will terminate the translation process on seeing the first error, because they are very simple when you are looking at the translation, that is capacity. But whereas a compiler, it has to find out as many errors as possible. We cannot claim that always every compiler will find out all errors which are available in a program. So, it will try to find out the errors and it is going for the next error, but how it is going for the next error is by doing some kind of repairing of the error which you have already detected. We are having some mechanisms for how the errors are that is the compiler is recovering from the error. So, we will be recovering from the error. So, while we are recovering, we will report it to the programmer saying that this is what the error which you have which the compiler has faced, and automatically the programmer will be aware of that this is what the error available in your program. And to report more number of errors available in the program, the compiler will continue with the compilation of the rest of the code by recovering from the already existing error. So, the compiler, it is first of all it is detecting the error, then it is reporting the error to the programmer for correction, and to find more errors it recover from the error, and once it has recovered it can continue with the that is compilation of the rest of the code. So, if you find that the compiler is more efficient, then it can even go for some kind of that is corrections of error also. So, recovering from the error itself is some kind of correction. We do some kind of correction, but those corrections carried out by the compiler for recovering process may not be the one which are intended by the programmer, but it is we need to find out that our intention is just recovering from the error and proceeding further to find out the rest of the errors. It is not about program correction. So, we will find out the mechanism for recovering as fast as possible and find out as many errors as possible which are available in your program. When there is a situation that your compiler is not able to proceed further because of too many errors we have reported, and we will be in a position where we will not be able to proceed further or we will not be able to recover further, then the compiler will say that okay, no progress, the program has too many errors, it will simply come out. Abruptly the compilation will be terminated, and the programmer has to do the correction of the already reported errors, so that the compiler will proceed with further. So, the compiler is actually reacting the error by three things. One is system crash, and or it may give you the invalid output, that is another thing, or it may be quitting with the first error. But most probably what we will be expecting is it has to report many that is errors which are there in the program. And now a more complex compiler, if you find that the compiler has been designed with sophisticated techniques for the recovery and repairing, then it will try to repair the error by transform the erroneous input into some legal input. So, based on some kind of input from the programmer. This is what the detection and recovery strategy. So, now the question is how a compiler has to report the errors, so that the programmer will find it very much helpful in correcting the errors with lesser difficulty. So, the first thing is the message should pinpoint the errors in terms of the original source language rather than the mysterious format. So, we have languages, and for that only the compilers have been written. The languages are having different syntax, that is constructs. One language may have one construct, another language may have a different construct, maybe in terms of the way in which the statements are presented, or in terms of the keywords which are there in the statements. So, we have to find out the exact way of communicating the error to the programmer. So, the programmer will not find out any difficulty in understanding what is the error. The second one is it should be understandable to the programmer rather than something like cryptic format. So, we should be clearly explain whether the error is going to be the syntax error. Simply the syntax error, if you are saying like that, the programmer may not be able to identify that. For example, missing semicolon, but what is the line number in which, or what is the function name where the syntax error, the semicolon is missing. So, what is the line number. So, these things are supposed to be produced. That is why we say that the next statement, the error must should be specific as well as they should localize the problem. We may have a very big program, maybe with 1000 lines of code, and the error is reported, but it is not mentioning about what is a function name and what is the line number in which the error has been detected. Then the programmer will be in a very difficult situation to find out, that is traversing the entire program to find where the error is available. So, it is required that the program error must be specific, and it should exactly find out what is the correct place where the problem has been detected. And another important thing is the error messages should not be redundant. This may happen most probably with the variable declaration and all. So, when we find that there is a variable declared in some part of your program, it may have large number of uses in many places of the program, but once there is something wrong with the declaration of the program, the program variable, the compiler may not be able to recognize that the variable has been declared. So, declaration missing. But if you report the error for every place where we have the usage of A, then it will be unwantedly producing too many number of errors. Actually, the error is because of only the variable is not declared. So, we should not go for redundantly producing the error messages, that will unwantedly flood the programmer with error messages. So, the error messages should not be redundant. Once the error message is produced, and if you are trying to, or if there is need for producing the same message, do not repeat it, because once that has been detected, the programmer will correct that. So, the rest of the errors will be automatically removed from the program. Now, there are certain types of errors. So, we have one is the, normally we will say that syntax errors. So, how these are all produced, one is called deletion error. We find that there are two number of opening brackets available, but there is only one closing bracket available, which means deletion is a error. And there is insertion error. This is a Fortran, that is loop statement. We have do 10 I, that means 10 followed by I, but there is a comma available, unknowingly somebody has put that and there is comma there. So, it is an error because of the insertion of this comma in this place in between 10 and I, and it is a replacement error. Actually, we are expecting a semicolon there, instead of semicolon we have a colon. So, that is an error called replacement error. And the another one is going to be the transposition error. Transposition means actually this is going to be a keyword called procedure. The spelling is PROCEDURE, but we have it as POR. It is when you type that, we have just that is transposed the symbols, instead of RO it has been typed as OR. So, there is one error. Another example for insertion error. So, we wanted to have a comment statement in C or in C++, where the comment starts with /* and it is ending with //, but it is mandatory that the star and slash should be consecutive symbols, and similarly here also, where it is starting or it is ending, they are supposed to be continuously available, but here we have a blank space in between that star and slash. So, which the compiler will fail to detect that there is an error because of the that is the command line. These are the types of errors. So, now how do you recovering from the errors? So, one simple solution is going to be the minimum distance correction for syntax errors. So, it is trying to find out the minimum harming distance method for the various error transformations. We will just define various transformations. Look at this example, like we have if, actually the statement is if a is equal to b, then sum is equal to sum plus a, that is going to be the statement. But the mistake is a deletion error. In between if and a, there is a blank space needed, but the blank space is missing, which means there is an error available in this. So, now we will try to define various transformations of length 1 or length 2 or length 3 or anything, but defining transformations with length 1 is okay, but length that is 2, 3, it will be producing very large number of transformations. So, it will be very difficult for generating that many number of transformations. So, when you are defining length of 1, then it can be something like inserting a symbol or deleting a symbol or replacing a symbol or transpositioning the symbol. So, these are the possible transformations applied on this particular that is statement, and now we have to find out. So, what transformation is going to have the most resemblance with this particular statement and having the valid syntax. So, in this case if we introduce a blank in between if and a, then we find the statement becomes valid. So, it is going to be read as instead of if a is equal to b, we read it as if a equal to b, then sum is equal to sum plus a. So, now we find that this statement, the transformation is going to be of length 1, that is error transformation is going to be of length 1. The resulting transformation is if a is equal to b, then sum is equal to sum plus a, which has the valid syntax. So, we will proceed by replacing this particular statement if a is equal to b, then sum is equal to sum plus 1 by if a is equal to b, then sum is equal to sum plus a, and we can, this is only a recovery, it is not a correction, it is only a recovery. So, we will be able to recover from this statement with the valid statement, so that the program compilation will continue with remaining errors. There are possible semantic errors also that can be detected either in compile time or even the runtime also. So, the most probable semantic error is going to be the undeclared variables or even invalid scope, something like a variable not declared but used. In usage, the statements may be valid statements. For example, an assignment statement a is equal to b means there is no error available on the statement, but it is a prerequisite that a and b should have declarations for having this as a valid statement, but that is going to be available in a different scope. So, that will be treated as a semantic error. Another one is the type mismatch with various statements, like a mod b is there. It is mandatory to have that a and b are as integers, but syntactically a mod b is okay, because there is mod is a binary operator, it requires two arguments, one on the left side and another one is on the right side. Since they are available, syntactically it is okay, but semantically they are wrong. It is going to be wrong because of their types are not as per the requirement. So, another thing is like the array bounds exception and all, these are also coming under the semantic errors. And now, if you are looking at the errors in various phases of the compilation, so we have the lexical analyzer, the syntax analyzer and the semantic analyzer. So, these are the three phases where it will be most probably we will be facing errors. So, there is a chance for even having the errors in the intermediate code generation that may be introduced by the compilation stages, maybe machine dependent or machine independent cases. But here the lexical analyzer, if it finds error, it will be automatically detected by the lexical corrector, which will go for the recovery by printing some error message. Then syntax analyzer, that will be detecting errors by the syntactic analyzer, and it may correct those errors by doing some kind of that is recovery strategies. And at the same time, for every recovery strategy, once it is carried out, appropriate error message will be printed, and all these are going to have some impact on your symbol table, because variable declaration and all are available only with respect to the symbol table. So, we will go for interacting the symbol table. Especially the semantic errors will be reported to the programmer only in consultation with the symbol table, because most of the errors which are considered as semantic errors are because of the type mismatches. Maybe the variable has been declared but not initialized, that may be a semantic error, or variables used but not properly declared, that is a semantic error, or dynamic values for the different variables or the type mismatch. So, there is a need for looking into the symbol table, so that we will be able to look at the or decide whether there is a semantic error available or not. So, this is what the various errors which we are seeing on the phases of the compilation, that is especially the front end. So, once this is over, we will be having the parse tree. The parse tree is constructed, means the program is free from syntactic and semantic errors, but there may be chance for having even runtime errors or even the errors during the code generation also. So, as far as this particular episode is concerned, we are having only these that is the errors in various phases, especially in the front end of the compilation. To summarize, we have seen the automatic parser generator, that is how that is if you are given an that is grammar which is having ambiguity, how we are constructing the parsing table for that, and later we have seen that is how the errors are detected and reported. So, the question components, maybe you will be given an ambiguous grammar, and we have to mention how the additional information required for that particular grammar are provided to the parser generator, so that the parser will continue parsing without any ambiguity or without any parsing action conflicts. Then how the syntax errors are handled, and what is the role of symbol table in handling the errors. These are the possible questions. So, with this I complete this episode. Thank you all.